Hey guys, welcome to the first lesson for our CSEC level of physics. Now, today we'll be looking at analyzing graphs. So we're not going to draw graphs today, we're just going to look at analyzing information from a graph, right? Because graph is a fundamental aspect of physics that you need to grasp in order to do well in your CSEC exam, because it's the first question on every paper, right? So a graph tells us the relationship between two quantities, right? So if you have two quantities, we remember we plot one against one. So we have, let's say, time on our y, and let's say length on our x. So in these cases, we're comparing quantity of time and length. So what the relationship when we change length, what happens to time, right? So from graph, we have two levels of graph, or two types that I normally talk about. We have our direct proportional, which states that if we increase the length, then time also increases, right? So if we look at numbers, if we increase from 1 to 3 for length, time also increases from 3 to 9. So we have a direct proportionality. So if they ask to find a relationship between two quantities, a quantity, the relationship, first one can be that they're direct proportional, right? And the opposite of this one is a one that we don't normally focus on, but it can actually happen, is inverse proportionality. So let's say this is time, and let's say this is temperature. Right, so this is inverse proportional. Inversely proportional, right? So if we move from time moving between from 1 to 3, right? So time moves from 1 to 3. So at 1 it is 6 degrees, and time 3 it's 2 degrees. So as time increases, we know that temperature decreases, right? So this is known as an inverse proportional graph, right? So these are the two graphs, straight line graphs, that we look at the CSEC level, right? So it can be either direct proportional, which is very popular, or the inversely proportional, which we do sometimes have to draw, right? So for today, we're going to look at first this popular equation that says y equals mx plus c, right? So this equation is known popular, right? Because it tells us, one, the quantity that's on our y-axis, two, the quantity that's on our x-axis, and this m here, you know, means gradient, right? And the c here is our y-intercept. Right? So this is very important in drawing any graph in physics, right? So the quantity that's always on the y-axis, it should be the subject of the equation, right? And then the one that's on the x, whatever is beside it, right? So whatever is multiplied beside it is our gradient value. And if we have a minus or add, then that's our y-intercept. Alright, so now we're going to look at how we can get information from first equation, right? So this equation is the equation of a pendulum, right, which we all know. So the pendulum, the t, periodic time, is equal to 4 pi square root of length of the pendulum over g gravitational acceleration. So the popular plot we normally use would be plotting t squared versus length, right? So if we plot t squared versus length, how can we use the equation to tell us certain things that we should expect, right? So the first thing is that, remember, whatever comes first would be what's on the y-axis, and then what comes second would be on our x-axis. So therefore, we need to make t squared the subject of this formula, right? So t squared, so in this case, if we square the t, we have to square what's on the right side as well. So it's t squared would be equal to 4 pi squared. We square this, the square root sign, so we get rid of the square root. So we get this, right? So now we have it in the form, because t squared now is our y-axis, L here is our x-axis. And remember, from y equal mx plus c, right, we have y and x, so that means whatever is multiplied by x is our gradient. So in this case, our gradient value would be 4 pi squared over g. And this is very important because the g here is actually being multiplied, because this is the same as 4 pi squared L times 1 over g. So this is being multiplied by L, while also the 1 over g is multiplied by L. So that's 4 pi squared over g is our gradient, right? And this is something important because when you plot the graph, CSEC normally asks you to find g, right? But if you're not aware that 4 pi squared over g is your gradient, then you're not going to actually answer that question correctly. All right, so we're going to actually look at the 2019 paper, right? The first question, and actually show a problem that student actually came to me having with the question. All right, guys, so the question actually will be posted here, but this is just a summary of what we'll be looking at. Because remember, we're just analyzing graphs, we're not drawing the graphs, right? Because I'm expecting that you should know how to draw graphs by now. If not, then you can leave a comment down below so I can do one on drawing graph itself, right? So they got a table, right? And they were supposed to plot Vs against Vp for a transformer, right? So some of you guys probably will not know what the transformer is now, but later on you'll actually learn about that. So in that case, this equation, so the first thing would be that you write an equation for the topic that you're drawing the graph for. So if it's not given, then it's your duty to write down the equation. So for a transformer, right, it is, we're given Vs, right, and Vp, and then if we look at C, it talks about Ns and V and P. So that means we use this part of the equation, right? But to write the full part, this is our equation for the gradient, for transformers, right? So because we're only focusing on V and N, we use this part alone, right? So remember, they said Vs against Vp. So that means Vs would be on our y, and Vp would be on our x-axis. So in this case, we would make Vs the subject, right? So if we make Vs the subject, then that means Vs would be equal to Ns Np times Vp, right? So now we have it in the format, because Vs now is our y-axis, Vp is our x-axis, right? So therefore, whatever is multiplied by Vp, that is our gradient, right? So after we plot our graph and we find our gradient, right, then we can get this, right? Because now we know that our gradient value, m, will be equal to ns over np. So we're given np and we're asked to find ns, which would be np multiplied by m. So we put in the value of np multiplied by your gradient value and you get your ns value, right? So this is basically the hardest analyzing graph I've seen recently from CSEC because students were not making the link between these things. Alright, so I hope today, guys, you learned about analyzing. If there's anything about graph you like, you can leave a comment and I'll get to you guys with a lesson about that. Thank you very much.